Okay, so we start with session with we have already discussed the information requirement. Now, let's take an example. How we can use how we can develop or how we can calculate or evaluate the usage matrix that which we have discussed in the last slide. That is usage QI, comma AJ. Now let's for that purpose consider four queries. As you can see, there are four various queries: Q1, Q2, Q3 and Q4. You can see yourself. Select budget from project where P number is equal to given value. Let's select P name from project, select P name and budget from project, and select some project budget from project where location is equal to value. So how many attributes are there? There are actually four attributes which are there in the project table. So we consider all the attributes. You can see A1, let's suppose is P number, A2 is P name, A3 is budget, A4 is equal to lock, which is a short form for location. So, when we develop the matrix, there are four queries. So on the left hand side, there are queries Q1, Q2, Q3 and Q4. And on the top, you can see there are four attributes A1, A2, A3 and A4. Now let's take the example Q1. Let's take, for instance, take Q1. So in Q1, you can see yourself that P number and project is being used. So P number is A1, so the value is 1. A2 is P name. So in the Q1, there is no P name, so the value will be 0. In Q1, query 1, the budget is there, so A3 is 1. And the LOC, that is location, which is not there in the query 1, so it is 0. Similarly, you can see for query 2. Query 2 is select P name, comma budget from project. So here only P name and budget is required. So P name is A2, so the value is 1. Budget is A3, the value is 1. Similarly, A1 is 0, A4 is 0. So in that way, you can develop the matrix that is called the usability matrix, QI, comma AJ. Here, four queries are given. That might be 6 queries, that might be 3 queries, that might be 7 queries. So in the same manner, you can develop the matrix. Okay, now that's clear. We'll move towards affinity measure, which is called AFF. Affinity measure, we call it AFF. And always remember that affinity is calculated among the attributes. Affinity is always calculated among the attributes. So that is why it is represented as AFF, and in the bracket you can see AI, comma AJ. That is called affinity. So the attribute affinity measure between two attributes AI and AJ of a relation R with respect to the set of applications or queries Q1 to QQ is defined as follows. How we calculate the affinity? Affinity of AI, comma AJ is equal to big sigma all queries that access AI and AJ, और bracket में अंदर क्या लिखा हुआ है? Query access. And what is query access? Query access is sigma of all sites. Access frequency of a query. What is meant by access frequency? एक क्वेरी अगर आप एक दफा एग्जीक्यूट करते हैं तो उसकी फ्रीक्वेंसी 1 होती है. अगर यही क्वेरी आप दोबारा एग्जीक्यूट करते हैं तो उसकी फ्रीक्वेंसी 2 हो जाती है, फिर 3 हो जाती है. अगर 10 दफा करेंगे तो उसकी फ्रीक्वेंसी 10 हो जाएगी. अगर 1000 दफा करेंगे तो फ्रीक्वेंसी क्या हो जाएगी? 1000 हो जाएगी. तो अगर एक दफा में नहीं करेंगे तो 0 होगी, वरना 1 होगी या फिर 1 से ज्यादा होगी. So access frequency of a query into access upon execution, that is the query access, and then we can calculate the affinity matrix. Now here try to understand that how it will be computed. Let's for a moment, for a simplicity of the problem, or to make it more simple, let's assume that each query in the previous example access the attribute once during each execution. बजाय इसके कि हम कहें कि बहुत दफा की थी, हम कह रहे हैं कि भाई उसने एक दफा तमाम एट्रीब्यूट को एक्सेस किया है. Also assume the access frequencies which is given to us. तो access frequency हमें मिल गई है. What is the access frequency? Access frequency here is between the queries and the sites. ये जो ऊपर लिखा हुआ है S1, S2 and S3, Basically, these are representing sites. So there are 3 sites, let's assume, and there are 4 queries. So query 1 is executed 15 times on site 1, query 1 is executed 20 times on S2, and query 1 is executed 10 times on S3. Similarly, query 2 is executed 5 times in S1, 0 times in S2, 0 times in S3, and query 4 is executed 3 times in S1, 0 times in S2, and 0 times in S3. So that is my access frequency. So how I will calculate the affinity? So how I will calculate the affinity? So affinity is always exist among the attributes, because AFF bracket AI comma AJ. So now here you want to calculate the affinities. So to calculate the affinities, what you have to do? You have to write down the same attributes on the column side and same attributes on the row side. Let's suppose if you have here in this example, we have 4 attributes. So you can see on the top of the matrix A1, see the column matrix A1, A2, A3 and A4, and see the row matrix. Again it is A1, A2, A3 and A4. अगर ये 5 होते तो 5 कॉलम बनते और ये पांचों रोज में भी आते. अगर ये 6 होते 6 कॉलम बनते 6 रोज में आते. Why? Because affinity is always calculated among the attributes. So now how the values will be computed, that is the problem. So let's suppose, let's see this position first, this one, this representing the affinity between A1 and A1, this representing the affinity between A1 and A2, this representing the affinity between A1 and A3, this representing the affinity between A1 and A4. So if you want to compute the affinity between A1 and A1, so let's suppose if you want to calculate the affinity between A1 to A3, here you can see that A1 और A3 को हम देखना चाहते हैं. तो हमें ये देखना होगा कि A1 और A3 कहाँ पर अपीयर हुए हैं. Where do these A1 and A3 appear? तो आप देखें A1 और A3 कहाँ अपीयर हुए हैं एक साथ. A1 और A3 सिर्फ क्वेरी 1 में एक्सेस हुए हैं. ये देखिएगा A1 और A3 को देख रहा हूं मैं. A1 A3, तो A1 और A3 दोनों एक साथ कहाँ इस्तेमाल हुए हैं? ओनली इन क्वेरी 1. क्वेरी 2 में सिर्फ A3 में आ रहा है. क्वेरी 3 में सिर्फ ये 0 0 है, ये 0 1 है. सिर्फ ये एक वैल्यू है, दैट इज क्वेरी 1 वेयर वी बोथ हैव 1 वैल्यूज. सो देयर alhamdulillah. So therefore the values is computed on only query 1, that is 15 into 1, क्योंकि हमने 1 अज्यूम कर लिया है कि 1 है, यानी हमने उसको सिंगल वैल्यू पे लिया है. 15 into 1 plus 20 into 1 plus 10 into 1, this value comes to be 45. So here you can see that it is 45. Now let's suppose I want to compute this value. This is the affinity between A1 and A2. Again, first check this matrix A1 and A2. How many queries they come together? Query 1 they don't, query 2 they don't, query 3 no, query 4 no. So in no query A1 and A2 coming together, so therefore their affinity will be 0. Now let's suppose we are interested to calculate this value, that is the affinity of A2 with A2, affinity of A2 with A2. In that case the affinity is calculated. In that case the affinity is calculated only on the basis of A2. So here you can see A2 is not there in Q1, A2 is in Q2, A2 is in Q3, and there is no A2 in Q4. So you only consider Q2 and Q3. So let's come to Q2 and Q3. 5 into 1 plus 0 into 1 plus 0 into 1, that is 5, plus 25 into 1 plus 25 into 1 plus 25 into 1, that is 75. 75 plus 5 is 80. So here you have the value 80. Similarly, you have A2 and A3. You can see yourself A2 and A3. What is the affinity value? The affinity value is 5. Go back and see A2 and A3. A2 and A3. See, only in query 2 they appear together. Only in query 2 they appear together. So it means only query 2 is applied. 5 into 1 plus 0 into 1 plus 0 into 1, the value is 5. Here you can see. One more thing which you must remember, that whenever you are calculating the affinities, so affinity of A2 with A3 or A3 with A2 will remain same. You can see here, for example, this is A2, A3, the value is 5. This is A2, this is A3, the value is 5. The value will remain the same. Similarly, if you are computing A1 and A2, that is 0. So again, that A2, A1 is 0. Okay, so in that manner, you can build this affinity matrix. This is not the end of the game, although you have to go for further calculations. But since now, up till now, what we have discussed, we have discussed how we can calculate the affinities.
Yes,
Okay,
sir.
okay. Now we apply the clustering algorithm. That clustering algorithm will help us to identify which attributes will come together to form the fragment. Take the attribute affinity matrix which we have developed in the previous slide, that is AA matrix, and recognize the attribute orders to form clusters, where the attributes in each cluster demonstrate high affinity to one another. अब क्या करना है हमने, अब इनपुट मेरी क्या हो जाएगी, affinity matrix, and we'll try to form the clusters. We will see which attributes are coming together. So therefore we need to find out the clusters, and for this purpose you have to apply an algorithm, which algorithm is called bond energy algorithm. The name of the algorithm is called bond energy algorithm, which has been used for clustering of entities. BEA finds an ordering of entities such that the global affinity measure is maximized. So in that manner, whenever we apply the BEA, so it always calculates the global affinity, and the global affinity values, whenever it is maximum value, there it will stop. It means that is the best possible cluster we have. Now, how we will calculate that global affinity measure and how we apply the bond energy algorithm, now we will start discussing this thing, okay? So here we are interested in the affinity of AI and AJ with their neighbors. So यहाँ पे हम affinity calculate करते हैं neighbors के साथ, यानी A1 है तो उसकी affinity A3 से ज़्यादा अच्छी है कि A4 से ज़्यादा अच्छी है. What we try to do is we'll try to find out the affinity or the closeness of the attributes with the neighbors. And neighbor means all those attributes which are there in the matrix. So in the bond energy algorithm, what is the input? The input is the AA matrix. It means if I give you any problem where you have the queries information, where you have the access matrix, you can easily develop the AA matrix as you have seen in the previous example. So when you want to apply the bond energy algorithm, the first thing is that you must have the attribute affinity matrix or AA matrix with yourself. And once you have the AA matrix, the output will be the clustering affinity matrix, which is called CA. So what is the output? The output is CA. Out of AA, what we'll try to do, we try to find out the CA, that is the clustered affinity matrix. Okay, there are 3 steps which you have to follow. Number 1, in the algorithm, number 1 is place and fix one of the columns of AA in CA. क्या करना है, जब आपने A फॉर्म कर लिया उसमें से कोई एक कॉलम उठाएं, पहले उसको रख लें. जैसे लेट सपोज मेरे पास A1 था, A2 था, A3 था, A4 था, आपकी मर्जी है. You can take A2 as first column, no problem. You can take it, you can fix it, and then you add the other columns. It's up to you. The second step is called iteration, because it's an iterative process, so it repeats. सो प्लेस द रिमेनिंग n माइनस आई, तो एक तो आपने प्लेस कर दिया, बाकी कितने बचे, 4 थे, एक प्लेस कर दिया, 3 बच गए। तो उन 3 में से आपने फिर एक को लगाना है पहली आइट्रेशन में, जब वो एक लग जाएगा फिर उस 2 जो रह जाएंगे उनमें से एक को लगाना है, फिर जो आखिरी है उसको लगाना है। तो then all the columns will be added in this in whatever manner which is required. But while you are doing this, you have to calculate the global affinity as well. So wherever the global affinity is more, you will make that column neighbor to that column. मसलन मैंने A1 को रखा, साथ A2 को लगाया, जब A2 को लगाया तो एफिनिटी कम आ रही थी, लेकिन जब A3 को लगाया तो ज्यादा आ रही है ग्लोबल एफिनिटी, तो मैं फिर A3 को A1 के साथ करूंगा. That is the manner which will move on. And once we will complete this, then the last step is called row ordering. Because as you know, the Gaussian elimination methods, and when you talk about matrix computation, you know that by row ordering we can adjust the matrix as well. So we can make the row orderings to make the clusters available. Okay, that is the 3 steps which are required for. These 3 steps are required for bond energy algorithm. Now please make attention and see carefully that how we will compute the bond. The best placement, defined contribution of a placement, is having a formula. And what is the formula? That you have to calculate the contribution, which is represented as CONT, which is represented as the contribution, which is represented as CONT cont. The contribution is always calculated among 3 attributes, and the formula is twice the bond of AI comma AJ plus twice the bond of AK and AJ and minus twice the bond of AI and AJ. यानी पहला और दूसरे का बॉन्ड प्लस दूसरे और तीसरे का बॉन्ड और माइनस twice of the bond of the first and the third, because contribution is always calculated among 3 attributes. So it is easier to remember. It is not that difficult. Twice the bond of a first attribute and second attribute plus twice the bond of the second attribute and the third attribute minus twice the bond of first attribute and the last attribute. And how you will calculate bond? Bond is calculated by multiplying the corresponding affinities, and we add the affinities. You can see the process in the next slide, then you can understand the process. Now see here, what is the input for CA? Your affinity matrix. This is your affinity matrix. ये अभी हमने पीछे भी बनाया था. That is called our affinity matrix. फिर हमने क्या कहा था? Take any attribute and fix it. Let's suppose you fix the A1. तो आपने क्या किया? A1 को फिक्स कर दिया. फिर क्या कहा था? आइट्रेशन है. आइट्रेशन में किसी एक कॉलम को आप उसके साथ मिलाएं. Let's suppose आपने A2 को मिला दिया. ये A2 को मिला दिया. ठीक है. अब आप कंट्रीब्यूशन निकालेंगे, तो आप जो कि ये 2 कॉलम है और 3 के दरमियान कंट्रीब्यूशन होती है, तो फिर हम क्या करते हैं, एक कॉलम हम ऐड कर लेंगे खुद ही से A0, और A0 की सारी वैल्यू 0 ले लें आप, तो क्या हो जाएगा A0, A1 और A2. तो कंट्रीब्यूशन निकाल सकते हैं आप. अभी पीछे फॉर्मूला दिखाया है, ये कंट्रीब्यूशन का फॉर्मूला है. A0, A1, A2 इनके दरमियान ये निकाल लें, कंट्रीब्यूशन निकल आएगी. ठीक है. दैट कंट्रीब्यूशन इज बेस्ड ऑन दिस बॉन्ड्स. और बॉन्ड कैसे निकलता है? मिसाल के तौर पे इन दोनों का बॉन्ड निकालना है, A1 A2 का. दैट इज 45 into 0 plus 0 into 80 plus 45 into 5 plus 0 into 75. दिस इज द बॉन्ड. अगर लेट्स सपोज मुझे A3 और A4 का निकालना है, तो 5 into 0 plus 5 into 75 plus 53 into 3 plus 3 into 78, ये जो भी अमाउंट आएगा दैट इज बेसिकली द बॉन्ड. और वो बॉन्ड किस में यूज हो रहा है? इस कंट्रीब्यूशन में यूज हो रहा है. Now that contribution is you can see here between A0, A3 and A1. इसका मतलब है यहाँ पर पहले मैंने A3 को प्लेस किया है, फिर उसके साथ A1 को ऐड किया और फिर A0 शुरू में ऐड किया है, तो A0, A3, A1. यहाँ पर क्या आ रहा है? A1 मैंने पहले रखा है, फिर A3 रखा है, फिर A2 रखा है. इन तीनों के दरमियान कंट्रीब्यूशन निकाल रहा हूँ. तो जब आप कैलकुलेट करेंगे, ये वैल्यूज नजर आ रही हैं आपको, ये वैल्यूज आ रही हैं. दीज आर योर ग्लोबल एफिनिटी मेजर. तो जो वैल्यू ज्यादा बड़ी आएगी वो कंट्रीब्यूशन सबसे बेस्ट है. इसका मतलब है कि उस कॉम्बिनेशन को मैंने रखना है। मसलन ये वैल्यू यहाँ पे ज्यादा आ रही है 10150, इससे लेस है ये 8820 और इससे लेस ये आ रही है। तो इसका मतलब है जहां ये वैल्यू मैक्सिमम होगी तमाम हम कैलकुलेट करेंगे, और जहां ये वैल्यू मैक्सिमम होगी उस ऑर्डर को मेंटेन करेंगे। So by doing so, that arrangement will come after the row ordering, that is A1, A3, A2 and A4. Similarly, A1, A3, A2 and 4, same combination will come over here. And now you can see yourself. अब जरा गौर से देखो, क्लस्टर नजर आ रहे हैं। अब आप देखें, ये आपको खुद नजर आ रहा है कि ये एक क्लस्टर बन गया, आपको खुद नजर आ रहा है कि ये एक क्लस्टर बन गया। इनके दोनों में यहाँ पे बहुत कम वैल्यूज आ रही हैं। इसका मतलब क्या है? इसका मतलब ये है कि A2 और A4 ये एक साथ आने चाहिए, और A1 और A3 एक साथ आने चाहिए। तो अगर मैं फ्रेगमेंटेशन कर रहा हूँ, इफ आई एम डूइंग द फ्रेगमेंटेशन, so I can keep A1 and A3 together and A2 and A4 together because they have strong affinities. ठीक है? So in that manner you can apply the bond energy algorithm. I repeat the bond energy algorithm again for uh, for for clarity. जो आप लोग सुन रहे हैं जरा और clarity आ जाए. How you apply the bond energy algorithm? Remember, you need AA matrix. If you have AA matrix, no problem. You can start bond energy algorithm. If you don't have AA matrix, then first make the AA matrix. Once you have the AA matrix, the first step is initialization. You can take any column and fix. It's up to you. जैसे A1 से A4 था, मैं जिसको चाहे पहले रख सकता हूँ। मैं A4 को रख लूँ, फिक्स कर दूँ, A3 को रख लूँ, फिक्स कर दूँ, A2 को रख लूँ, फिक्स कर दूँ, A1 को रख लूँ, फिक्स कर दूँ, मेरी मर्जी। और उसके बाद क्या करूँ? उसके बाद एक दूसरा कॉलम आइट्रेशन में आ जाएगा। अगर A1 है तो फिर A2 आ जाए, या A3 आ जाए, फिर A4 आ जाए। तो जैसे ही दो कॉलम हो गए A1 और A2, तो एक कॉलम हम ले लेंगे ऑन द लेफ्ट A0, ताकि तीन कॉलम के दरमियान तीन कॉलम्स हो जाएंगे। देन वी कैन कैलकुलेट द कंट्रीब्यूशंस which is equal to twice the bond first attribute and the last attribute plus twice the bond the second attribute and the third attribute minus twice the bond first attribute and the last attribute. So you can calculate the contributions. And how you calculate the bond? बॉन्ड कैलकुलेशन कैसे होती है? दो के दरमियान होती है। दोनों की एफिनिटी को मल्टीप्लाई करें, ऐड करते जाएं, आपको फिगर आ जाएगी। दैट इज द बॉन्ड। सो यू कंटिन्यू विद द आइट्रेशन, और वो आइट्रेशन कब तक करेंगे? जब तक कि आपको मैक्सिमम ग्लोबल एफिनिटी मेजर नहीं मिल जाता। तो जहां मैक्सिमम ग्लोबल एफिनिटी मेजर मिल जाता है, इट मींस वहां रुक जाएंगे, फिर रो ऑर्डरिंग करेंगे, एंड देन यू कैन सी that you can end up with this type of matrix which is called CA matrix, and that CA matrix now represents the grouping or clustering. You can see yourself and easily identifiable that अगर मैं इस रिलेशन को दो में तोड़ूंगा तो एक रिलेशन में A1 और 3 को रख सकता हूं, और दूसरे रिलेशन में मैं A2 और A4 को रख सकता हूं। That is the that is क्या कहना चाहिए, मेरे पास एक क्वाइट एविडेंस है कि मैं वर्टिकल फ्रेगमेंटेशन कर सकता हूँ। लेकिन अगर ये सब करने के बाद भी क्लस्टरिंग नहीं आ रही है, क्लस्टर नहीं बन रहे हैं, तो फिर इसका मतलब है यहाँ पर वर्टिकल फ्रेगमेंटेशन शायद एप्लीकेबल ना हो, जरूरी ना हो। ठीक है? So it all depends on this. With this, I conclude over here. If you have any questions, please go ahead.